this is an estimation question. You can tell by it being late on the paper, question 7, and it's talking about a sample. That is the hint. It's something to do with estimation because it's to do with the sample of 80 people, and you have to find the population mean. Okay, so this is a difficult question. They usually are. Okay, because I'll read it. The volume of water, V, used by a guest in an ensuite shower room at a small guest house may be modelled by a random variable with mean mu litres and standard deviation 65 litres. A random sample of 80 guests using the shower room showed a mean usage of 118 litres. Give a numerical justification why V is unlikely to be normally distributed. Okay, V is this is not numerical, just thinking about it. V, if you have normal distribution, it looks like that, and you have 118. Okay, the normal distribution continues there for very big values. People who wallow in the bath, but it also continues here. So if that is negative, it's not possible to be normally distributed. Because if it's negative, you can't have negative use of water in the shower, okay, and so that is why it's not likely to be normally distributed. But you may have to give it a numerical justification. Okay, so we know logically why it can't be. Okay, so the key is the standard deviation is 65. Okay, so imagine we were going to look there at the ends, there the key, 2. So imagine we are going to look at two standard deviations away from the mean. Okay, then we'll do Z equals x minus mu over. Okay, that is always useful. Okay, and Z is minus 2 in this case. The standard deviation is 65. Mu is 118. So I'll write it again. Minus 2 x minus 118 over 65. Okay, so then think about it to work it out. A minus 130 that times 2 equals x minus 118, and you plus. Okay, it can't be possible. You can't have negative. I can't remember what that number is. 12. Yeah, 12. Okay, you can't have negative 12 volume, so it can't be normally distributed, and that proves it. You know, you are only 2 standard deviations away from the mean, and that you should be able to get a result. You can't get a valid result, so it's not normally distributed. Okay, that is the first bit. Okay, so that is done. Okay, so explain why the mean volume of water of a random sample of 80 observation may be assumed to be normally distributed. Okay, we can assume it's essentially they're asking about the central limit theorem. Okay, when we know means are usually normally distributed, so when you have a big sample, bigger than 30, I've never considered 30 a big number. Okay, so when the sample of size is bigger than 30, you can use the central limit theorem, which says they're all approximately normally distributed. So we put that sample is bigger than 30, so it's quite big. So 80, quite big. Okay, and whenever it's quite big, you use the central limit theorem. Okay, 1 mark for that and 1 mark for that.